Good morning, dear students. Welcome back to physics class. In today's class, I am going to discuss on four topics. They are A. Important features of surface tension. B. Angle of contact. C. Excess of pressure across a curved surface. And D. Capillary rise. Let's learn about what are the important features of surface tension. You know that surface tension is a force per unit length or surface energy per unit area acting in plane of interface between liquid and any other substance. Its mathematical expression is given as S is equal to Fd divided by 2dl, or it is work done or surface energy divided by surface area. Then it is equal to F divided by 2L. It means the extra energy that molecules at interface have as compared to molecules in interior, which is considered as first feature of surface tension. And second feature is at any point on interface besides boundary, we can draw a line and imagine equal and opposite surface tension forces S acting perpendicular to the line in the plane of interface. This line is in equilibrium. To be more specific, imagine a line of atoms or molecules at the surface. The atoms to the left pull the line towards them. Those to the right pull it towards them. This line of atoms is in equilibrium under the tension because these two forces are equal in magnitudes but opposite in direction. Now you are going to study a new concept. It is angle of contact. Generally, surface of liquid near plane of contact with another medium is curved. Angle of contact is angle at which a liquid interface meets a solid surface. It is denoted by theta. It is different at interfaces of different pairs of liquids and solids. The value of theta determines whether a liquid will spread on surface of solid or it will form droplets on it. Example is droplet of water on lotus leaf as shown in given figure. The droplet of water, which is liquid, is in contact with the solid surface, which is leaf. This liquid surface makes some angle with the solid surface. This angle is known as angle of contact. Second figure shows water splits on table. You should understand angle of contact is the angle between the line which has drawn tangentially to the curved surface of the liquid at its interface with respect to air and the solid surface. What are the significance of angle of contact? You know, angle of contact determines whether a liquid will spread on surface of a solid or it will form droplets on it. If angle of contact is obtuse, that is, it is greater than 90 degree, then droplet will be formed. And if angle of contact is acute, that is, it is lower than 90 degree, then water will spread. See the two different cases. First case is when droplet is formed. Consider we have a solid surface, droplet of water, which is in contact with liquid and air. The solid-liquid interface is denoted by S SSL, solid air interface is denoted by SSA and liquid air interface is denoted by SLA. The angle which SSL makes with SLA is greater than 90 degree. That is, angle of contact is greater than 90 degree, then the droplet is formed. And second case is when water just spreads. Here, the angle which liquid forms with the solid surface is less than 90 degree. Since the angle made by SLA with respect to SSL is acute, so the water will spread over the solid surface. Consider the surface tensions at three different interfaces. They are solid-liquid interfaces, solid-air interfaces, and liquid-air interfaces, which are shown in given figures A and B. At the line of contact, the surface forces between three media must be in equilibrium. From the figure B, the following relation can be easily derived, which is SLA cos theta plus SSL is equal to SSA, or SSA is equal to SSL plus SLA cos theta. It shows the surface tension at solid air interface is equal in magnitude but opposite in direction to sum of surface tension at solid liquid interface and the horizontal component of surface tension at liquid air interface. The angle of contact is an obtuse angle if SSL is greater than SLA, which is in the case of water-leaf interface, while it is an acute angle if SSL is lower than SLA, as in the case of water-plastic interface. When theta is an obtuse angle, then the molecules of liquid are attracted strongly to themselves, and consequently the force of attraction of liquid molecules with the solid molecules, it is the adhesion, is weak. It costs a lot of energy to create a liquid solid surface. So, the liquid cannot make wet the solid. Let's answer the following questions. First question is, why are soaps, detergents and dyeing substances used as wetting agents? Because when they are added, the angle of contact becomes small, so that these substances can penetrate well and become effective. And second question is, how do waterproofing agents work in clothes? Its answer is, when waterproofing agents are added, they create a large angle of contact between water and the fibers, so that water cannot move through the fibers to make wet the clothes. Next topic is excess of pressure across a curved surface. Did you think ever, why are water drops and bubbles spherical? In earlier class, you studied the liquid has a tendency to make least possible surface area. Whenever liquid is left to itself, it tends to acquire the least possible surface area, so that it has least surface energy, so it has most stability. You should mean the lowest surface area stands for the lowest energy. which can be achieved by getting the spherical shape. So, for more stability, they acquire the shape of sphere, as sphere has least possible area. It is one consequence of surface tension, as the effect of gravity is neglected. Now, let's learn how to distinguish among drop, cavity and bubble. The figure given shows a water droplet. It is a spherical shaped structure filled with water. It has only one interface. This interface separates water and air. There is another interesting consequence of surface tension is that pressure inside a drop is greater than the pressure outside. Suppose a spherical drop of radius r is in equilibrium. If its radius increases by delta r, then extra surface energy will be equal to surface tension S multiplied by increase in area, which is W is equal to SLA into 4 pi r plus delta r whole square minus 4 pi r square, which is equal to 8 pi r delta r SLA, which is the expression 1, where SLA be the surface tension at liquid air interface. At equilibrium, extra surface energy is equal to energy gain due to the pressure difference, which is Pi minus Po, where Pi be the pressure inside the drop and Po be the pressure outside the drop. Then energy gain is W is equal to Pi minus Po into 4 pi r square delta r, which is the expression 2. Here we have used the expression for work done, which is force into displacement, whereas force is equal to pressure difference into area and the displacement as delta r. Using the expressions 1 and 2, we get Pi minus Po is equal to W divided by 4 pi r square delta r, which is equal to 8 pi r delta r SLA divided by 4 pi r square delta r is equal to 2 SLA by r. Then Pi minus Po is equal to 2 SLA by r, which is the expression 3. In case of a bubble, there are two interfaces. First one is air-water interface and second one is water-air interface. Consider a soap bubble. There is air inside and outside it, but it consists of thin film of water. You should notice that pressure inside a bubble is greater than the pressure outside it. We have the expression Pi minus Po is equal to 2 SLA by R, which is in the case of a drop. As the bubble has two interfaces, then the expression will become as Pi minus Po is equal to 2 SLA by R into 2. Therefore, Pi minus Po is equal to 4 SLA by R. In general, for a liquid-gas interface, the convex side has a higher pressure than concave side. Then, what is nature of cavity? It is a spherical shaped region filled with air. In surrounding there is water and in middle there is cavity filled with air. There is only one interface which separates air and water. Example is bubble inside the aquarium. On next, I am going to teach you another important topic which is capillary rise. In Latin, the word capilla means hair. Due to the pressure difference across a curved liquid air interface, the water rises up in a narrow tube in spite of gravity. Consider a vertical capillary tube of circular cross-section of radius small letter a inserted into an open vessel of water. The contact angle between water and glass is acute. Thus, the surface of water in the capillary is concave. As a result, there is a pressure difference between the two sides of the top surface. This is given by Pi minus Po is equal to 2S by R. From the figure B, which is the picture of the enlarged interface, let R be the radius of the spherical region of which the curved interface is to be part of, A be the radius of the circular cross-section, and theta be the angle between R and A. As shown in given figure, we have constructed a right triangle. We know that cos theta is equal to adjacent side divided by hypotenuse. Then hypotenuse R is equal to A divided by cos theta. Since 1 by cos theta is equal to sec theta, then R is equal to A sec theta. So the expression will become as Pi minus Po is equal to 2S by R is equal to 2S by A sec theta, which is equal to 2S by A cos theta, since cos theta is equal to 1 by sec theta, which is the expression 1. Thus, the pressure of water inside the tube just at meniscus air-water interface is less than the atmospheric pressure. Consider the 2 points A and B and assume that the pressure at the point A and the pressure at the point B are same. Then we have the expression PA is equal to PB plus H rho g. Here PA as Pi and PB as Po. Then Po plus H rho g is equal to Pi, which is the expression 2, where rho be the density of water and H be the capillary rise. By using the expressions 1 and 2, we get H rho g is equal to Pi minus Po, which is equal to 2S cos theta by A, which is the expression 3. Then the capillary rise H is equal to 2S cos theta whole divided by rho Ga, which is the expression 4. You should understand the capillary rise is due to the surface tension. It is larger for a smaller radius. This capillary rise is shown in figure A. Dear students, today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay, thank you. Have a nice day.